This is the second program, second experiment. Programming a PLC for batch process. This is the batch process. This is the batch process. Batch process means, you know the difference, already you studied process control, that's why you know the difference between batch process and continuous process. Continuous process will run forever, at least for 3 months or 6 months. After that, deliberately they will stop to check whether the instrumentations are correct or not. For service only, routine service only, they will off. Otherwise, it will continuously run. If any instrumentation fails, it leads to accident. That's why they will turn off after 3 months or 6 months. That is called a continuous process. Batch process means it will be used to manufacture syrup, tonic. So whatever the batch number will be there and the packing this is for legal purpose. So they will keep one set with them and one will be with the government. If any problem is there, that will be goes under legal proceedings. That's why there will be batch number that shows at which batch it is manufactured. If you know that number on which date it is manufactured, they can find from their ledger. So this is one such batch process. Here it is a tank. Yeah, tank is there. The tank will be filled up to this point. Then the heater will be turned on. The heater will be turned on. For that, there is a temperature sensor and the set point is there. Once that set point is reached, the sensor output will be 1. The temperature reached means the output of that sensor will be 1. The temperature is not yet reached, that set point means it will give 0. So once the temperature is reached, the temperature transmitter will give 1. That will be used to turn off the heater. Heater will be turned off. Always you need a stirrer, because otherwise the temperature will not be uniform in the entire tank. That's why a stirrer is there. That stirrer, whenever you turn on the heater, the stirrer has to be turned on. Stirrer will be connected at Y3. Stirrer will be connected at Y3. So once the temperature is reached, then we have to wait for some time. Say 50 seconds or 100 seconds, we have to wait. A delay timer will be there. During that time, we have to wait. After that, we have to drain. So actually what is happening? We cooked something in the container. We are filling the tank, heat it, stir it and heating it till the required temperature reaches. Once it is reached, we will keep in that temperature for some time. Then we are draining the tank. That's all. That is called one batch process. One batch process. You understand this? Now we have to turn on the inlet valve, means tank will fill the liquid. It may be syrup or something. Some liquid will come. For that, we have to open the valve. Y1 has to be, it will fill by gravity. Gravity will be used to fill the tank. So just to open this valve Y1, it will fill the tank. Before opening, what and all has to be checked? What and all has to be checked? What and all has to be checked to fill the tank? Before that, let us remember what are the variables used. And here itself I will draw that. So this is the input image, input module. This is the input module, PLC. This is output module. This is output module. What and all input? This is the tank must be empty. Tank must be empty first. Then only you can fill. Already it is filled, means why you have to open the inlet valve. Therefore, to indicate whether the tank is empty or not, one proximity switch. This is called what? Proximity switch will be there. That proximity switch will give 1 if the tank is empty. That proximity switch will be fitted in the bottom of the tank. That will give 1 the tank is empty. That will give 0 if the tank is not empty. The tank is not empty means not empty means it will give 0. Empty means it will give 1. Therefore, one of the input is x2. Another input is there. If the tank is full, this proximity switch will give 1. If the tank is full, x3 will be 1. x3 will be 1. Another proximity switch. So instead of push button, we are using some sensor, proximity switch to sense the process variable. Here, if the tank is full, that proximity switch will give x3 equal to 1. If the tank is not full, it will give 0. The tank is not full, it will give 0. 2 inputs. One more input we are going to use to turn on this batch process. We are going to use a push button that is connected to x0. That is connected to x0. One push button is going, we are going to use. That is push button. That we are going to use. That is x0. We are going to use turn on the batch process. Another push button to turn off the batch process. We are going to use x1. So x0 push button is normally open. This is normally open push button. Normally open push button. This is also normally open push button to turn on and off. X3, X2 is to check whether the tank is empty or not. X3 input is to check whether the tank is full or not. Next, it is not sufficient. If the tank is empty, we can open inlet valve. Where inlet valve is connected? At Y1. Inlet valve is connected at Y1. We can open inlet valve if the tank is empty. It is not sufficient. The outlet valve must be closed. The outlet valve, otherwise, if you open, it will drain away. It will drain away. That's why we have to check whether the outlet valve is closed or not. Outlet valve is closed or not. That we have to check. Yes. We have to check outlet valve also. Then Y2 is used to turn on the heater. Y2 is to turn on the heater. Y3 is to turn on the stirrer. Y1 is turn on inlet valve. Y4 is to turn on outlet valve. If this is Y4 equal to 1 means the outlet valve will open and drain the tank. Start draining the tank. Why not? Why not is nowhere mentioned. Okay. Based on the diagram, they wrote the program. That's why not is not used. Okay. So now we have to do the hardware wiring. A push button is required to turn on. This is plus 5 volt, plus 5 volt. It is connected to X0. This is to start. Another one is there. Another one is there. That is connected to X1. That push button is to stop. Proximity switch. X1 is there. X2 is there. X2 is there. That shows empty 1 or 0 to show whether the tank is empty or not. X3 also connected. That gives 0 or 1, depends upon if the tank is full, it will give 1. If the tank is not full, not empty. Not full means it will give 0. So that will give, these are the inputs. Outputs, Y1 is inlet valve. Inlet valve. Y2 is for heater. Y2 is to turn on the heater. Y3 is to turn on the stirrer. Y4 is to turn on the outlet valve. Outlet valve. Any other output? No. That's all. X4 is there. One more input is there. If the temperature is reached, this temperature transmitter will give 1. If the temperature is reached, that is connected to X4. So how many inputs? X0, X1, X2, X3, X4. 5 inputs. How many outputs? 4 outputs. Y1, Y2, Y3, Y4. That's all. Now we have to write the program. Here itself we can write. X0. Push button X0 is to turn on. X1 is to turn off. Let us put M0. Memory variable M0. We'll use M0 everywhere. To stop all runs, it is better to use one variable to turn off all runs so that we can use in every rung M0. So M0 ceiling contact is required. That is marked here. So M0 as third rung is M0. Now we have to open this valve. Before that, what and all has to be checked? Whether the tank is empty or not. For that, X2 will give 1. X2 will give 1. Therefore, you put M0 Y, the program is running. Then next thing is X2, if you put, the tank is empty. M0 is 1, X2 is 1, then we can open the inlet valve. It is not sufficient. Whether the outlet valve is closed or not, otherwise it will drain, you know. That's why we have to include that outlet. Outlet, you see, if the valve is open, it is 1. Y4. Y4 is used for that. If it is 1, it is open. If it is 0, means it is closed. It must be closed. That's why a 0, Y4 must be 0. That must be 1 here. That's why we are putting normally closed contact Y4. So if Y4 is there, then we can use. That's all. Now we can turn on inlet valve, but it is not sufficient. But it is not sufficient because if you open some valve, there must be a provision to close. Otherwise, tank will overflow, you know. When we have to close, the tank is full, we have to close. So if it is empty, if it is not full, not empty, here not full. 0 means not full, not empty. Not full. So if it is not full means it is 0. 0 means we have to include that also, X3 also. X3. Then what is the inlet valve? Y1. Is it sufficient? What and all we are checking? M0. That means program is turned on. X2. It means tank is empty. Y0 bar. It means outlet valve is closed. Next one is X3. Tank is not yet full. Tank is not yet full. These are all required to turn on Y1. We turned on Y1. Now tank is start filling. Is it sufficient? Whether it is completed? Whether it is completed? No, because if it starts filling, what will happen? This level will raise. Am I correct or not? This level will raise. If it goes above this proximity switch, it will give you a 0. Because tank is not empty. Tank is not empty. That's why it will give not full, not empty. Here we have to write not empty. Not empty. Not empty means it gives 0. Empty means it gives 1. Full means it gives 1. Not full means it gives 0. That way we have to write. The diagram is not correct. So not empty. If the level starts filling means it is not empty. That's why it will give 1. Empty means it will give 1. If it is not empty means it gives 0. That's why the logic will be changed. Once the level reached the first proximity switch, the logic here will be changed. The logic here will be changed. That's why inlet valve will be closed. You cannot open till it fills. That's why across X2, we have to connect Y1. Across X2, we have to connect the ceiling contact Y1. Y1 is connected across X2, because after some time it becomes 0, that time the Y1 will conduct. That time the Y1 will conduct. I understand this point. So these are all we have to think and write, no other go. So now the program will fill till the tank comes up to full. So once the tank becomes full, what is the value of X3? X3 becomes 1. X3 till now X3 is 0. When the tank becomes full, you notice that when the tank is full, what is the signal it gives? 1. 1 means this becomes 0. That's why inlet valve will be closed. Inlet valve will be automatically closed. It is working automatically. Inlet valve automatically works. The tank is empty. Outlet valve is closed. It is not full. It is not full. And if the level raises, then we need a sealing contact. That also we have put Y1. So that's why it works fine. Y1 is working fine. The tank is empty. Automatically the valve will open and it will fill till the tank reaches full. Till the tank reaches full. That's all. Now what we have to do? What is the sequence of operation? Next sequence is we have to turn on the stirrer and heater. Both should be turned on. When we have to turn on the heater and the stirrer, that we have to write. When we have to turn on the stirrer and heater, when we have to turn on the heater, the tank is full. The program is turned on, M0. The tank is full. Tank full means X3 equal to 1. We can put the X3. Tank is full, then only we have to turn on the heater and the stirrer. Any other thing? Any other thing? X4. X4 will give 1 if the temperature is reached. Now it is not yet reached. Now it is in room temperature. That's why what is the value of X4? It is 0. So it should give 1 to turn on the heater. That's why we have to put the X4 not, because now X4 is 0. We have to convert this into 1. Now it will give 1. M0 is 1. X3 is 1. X4 bar also 1. Can I turn on the heater? Yes, we can turn on the heater. But there is, if the temperature is reached, automatically it will be turned off. Automatically it will be turned off. So here heater is at Y2. One more output is there. That is Y3. That is stirrer. Both will be turned on if the tank is full. In 2 ways we can operate the heater. One is we can keep the temperature at required level, then turn off and keep for 100 seconds or 200 seconds, then we can drain. That is one way of programming. Another one is you want to keep the temperature at the set point means we have to again, if the temperature falls below that set point, the heater again turned on means we have to include that also in that run. I understand this point. Suppose temperature we want to keep 100 degrees centigrade. Now 100 degrees reached. Now we are keeping this X4 becomes 1. That's why heater is turned off. We are keeping for 5 minutes. We are keeping the tank as such in the temperature. But temperature falls below 100 degree means it is not good, means we should turn on again the heater. In that case, we have to include for that also. Have you understand that? Otherwise, it is okay. Otherwise, it is okay. To reach temperature of set point, X4 will give 1. Till then, the heater and the stirrer will be working fine. So, how long it has to wait? It has to wait in that program, in the requirement it is written. It has to wait 5 minutes. It has to wait 5 minutes. We cannot simulate for 5 minutes. We cannot wait 5 minutes to simulate. Let us put some 25 numbers. That's all. But 5 minutes it has to, we have to keep it and the temperature. So we need a timer. We need a timer. How to turn on the timer? When we have to turn on the timer? To turn on the timer, M0 must be 1. M0 must be 1. Tank must be full. Tank must be full. Am I correct or not? Tank must be full, X3. Then X4, yes, let us use X4 also. X4, it reaches set point. So X4, then if you put X4, suppose timer is 5 minutes, means the temperature falls, what will happen to X4? It becomes 0, you know. That value will change. That's why if you put X4, that problem will come. Have you understand that point? So we have to think, okay, anyhow, X4 we are putting, then we can use Y2. If Y2 is tank is full, once the heater is turned off, then only we have to turn on the timer for waiting period. For waiting period, when we have to turn on the timer? After heating. When heating is over means we can use the heater instead of X4. Instead of X4, we can use the heater. So in place of X4, we can use Y2. Y2, not Y2, Y2 bar. Once it is turned off, it will be turned on. So tank is full, heater is off, M0 is 1, so timer will be turned on. Timer will be turned on. But at the same time, any other thing has to be included? X4 is included, but in the record note, X4 is there. But if you think practically, it will not work out. But here in simulation, it will work. We will keep X4 1. Simulation, it will work. But in practice, before 5 minutes, the temperature will fall, means that the value will change, you know. In practice, it will not work out. Anyhow, if you want, you can include that also. X4. Then we have to put the timer. So let us assume that temperature at set point. So now we can put the timer. 5 minutes. 5 minutes delay timer. After that, what we have to use? After 5 minutes, we have to open the valve, outlet valve. We have to open the outlet valve. So to open that outlet valve, what and all required? M0 must be there. Program must be run mode. That's why M0 is required. Then what is required? T0 must be on. That T0 must be 1. T0 must be 1. Then heater must be turned off. Heater must be turned off. Heater Y2. Heater should not be on. Any other thing? That's all. The output is Y. Outlet valve is Y4. Outlet valve will be open. Will it work? Tank level must be 1. Tank level must be 1. That is not included. Let us include that also. Tank level X3 must be 1. And M0 is there. M0 is there. So will it work out? The tank is full. Heater is turned off. Y2 is what? Y2 is heater is turned off. T0 is timer is on. Timer will be on. So X3 is 1 means, will it work? Now the valve is opened. That's why level will fall. After some time, X3 becomes 0. The level falls below this proximity switch. The level becomes 0. It is not full. That's why it will not work out. That's why we would put a sealing contact across this. We would put a sealing, but here it will work. While heater is turned on, we are not draining. There it will work, but here it will not work. If this becomes 0, X3 becomes 0, timer output also becomes 0. That's why we would put across these two. This Y4 should be across these two. Across these two. That's all. Across these two. Then it will completely drain. But is it sufficient? When the valve has to close, when it becomes empty. That's why it is not empty has to be included. Empty means what? 1. X3, X2 is 1 when it is empty. Not empty means it is 0. That's why we have to include X2 here. We have to include X2 here. So we have to include X2 not here. So once completely drained, automatically valve will be closed. Automatically valve will be closed. Anyhow, we are checking there. While opening inlet valve, we are checking there. If we didn't include, it will not close. It will not close. That's why it will not open the inlet valve. If you didn't include the x2 here, so always if you write some logic for opening means, you must include some logic for closing also. This way you have to remember. While writing program, if you include something for opening means, you should include something for closing also. So here for closing, we included x2. For opening, what and all we included? M0, x3, T0, y2 bar. 4 inputs are in series to open the valve. To close the valve, x2 is sufficient. The tank is empty, it can be closed. The tank is empty, it can be closed. Once it becomes 1, it becomes 0, so outlet valve will be closed. Why we put the sealing contact across T0 and x3? Because once it start draining, x3 will not remain 1. That's why timer will be turned off. So across timer and x3, we put the sealing contact. We put the sealing contact. That's all about that program. So you are going to simulate this. The first one is M0. Already hardware wiring already we have seen. Hardware wiring is here. So we are using normally open start button, normally open stop button. And we should remember the proximity switch status. If it is empty 1, if it is full 1, otherwise 0. Empty 1, full 1, otherwise 0. We have to remember all this while writing the program. Okay. Now we have to include x0 to turn on, x1 bar to turn off this program, and we have to include M0 memory variable to keep the program running or off. You need a sealing contact. You need a sealing contact. That must be M0. That's all. So M0 will be 1 if you push the start button. If you press X1, it will be stopped. At any point of time, you can stop. So now, one more thing I want to mention, but you will not have such a situation. If you stop in the middle, you cannot run again. Sometimes the signal, the program will not allow to run, because we are writing the program for sequence of operations. The sequence is correct, then only the program, that batch process will work. If some other situation comes, it will not work. None of the run will run. I understand this. That's why if you stop in the middle, it may not work. So while simulating, you have to give correct signal sequence here. While if you want, really, if you want to write a program for real time, then you have to think many things. But we are not doing that level. So suppose if you stop it in the middle, no logic is satisfied means it will be as such. Suppose the tank is 50%. You stop it in the middle. You cannot drain, because when you can turn on the outlet valve, the tank is full. But you stopped in the middle. The tank is not full. How you can open the valve? You cannot open the valve. So those provisions we have to provide in the program. Now we understand this, but we are not doing like that. It is not a complete program. We are just simulating to understand the PLC. That's all. Do you understand this problem? Okay. Then we have to put the M0. M0. M0, X2, Y4, X3 bar. We will put X0, X2 first, so that it looks nice. Otherwise, you have to put 2 vertical lines. To avoid that, let us put X2 first. X2 first. Then M0. X2 first. X2 first. Then M0. Then M0. We have to open the valve. What and all we checked whether the outlet valve is closed or not. Why not bar? Why not bar? Why not bar? Y4 bar, sorry. Y4. Y4 bar. Then Y4 bar. Then X3 bar. Why? The tank is to close the outlet valve, it must be X3 bar. X3 bar. So we have to include X3 bar also. X3 bar. It is not full. Then X3 bar is because if it is full, it will be 1. It should be 0 to fill the tank. Outlet valve is Y. What is that? Diagram is Y. Inlet valve is Y1. Y1. Inlet valve is Y1. So we are checking whether the X2 means what? Whether the tank is empty or not. M0 is whether the memory variable is 1 or not. Y4 is whether the outlet valve is closed, whether the tank is not full. But this X2 is, this will not work out after some time, because if you start filling, the proximity switch first it will be merged inside the liquid. That's why it will not give 1 after some time. It's not empty. That's why we have to put a sealing contact here across X2. Across X2, we have to put a sealing contact. Across X2, we have to put a sealing contact to Y1. We have to put to Y1. To keep this on. To keep this on, we need this. That's all. Now, the inlet valve will open and fill the tank. That part is over. Now we have to turn on the heater. If it is full, the inlet valve will be closed automatically. By using a X3, automatically it will be closed. Now we have to turn on the heater. To turn on the heater, what and all required? M0 is required. And the tank must be full. Tank must be full. Then what and all we included? M0 is required. X3 tank is full. X4, what is X4? It is not reached the set point. These 3 we have to include. So now let us write that you need M naught. M0 is required. M0 is required. The tank must be full. For that, the signal is X3. X3 must be 1. X3 must be 1. Then third point is when it has to stop, when it reaches X4, when X4 is not 1, the heater should be on. Therefore, when it is not 1, that's why we have to include one more not. It is not 1, which is X4. X4 is not 1. Yes. Then the timer should be started. The timer should be started. The timer. Heater, sorry. Heater. Heater is what? Why? Y2, okay. But it is not sufficient. When it has to be stopped, the heater has to be stopped when it reaches this, okay, set point, that's all, okay. It works fine, but we have to include one more contact, that is stirrer has to be included, that is Y3, and it should be connected and yes, Y3 is connected. Now we have to wait for 5 minutes. We have to wait for 5 minutes. What are the conditions required? M0, the memory variable M0 is required. M0, okay. Then the tank must be full. X3 is required. Tank must be full. X3 is required. Then X4 is required. Because X4 it means the temperature is reached. That's why X4 is required. X4 1. So X4 is required. Once it becomes 1, the temperature is reached. Any other thing has to be included. That's why heater should be turned off. That's why Y2 bar. Y2 bar. Y2 bar. We can press function keys F1, F2, F3. Here, to press the function key, I have to press shift. That's why I am using this. There, if it is PC, you can use function keys. So, Y2, what is the heater? Y2, okay. Now, what is the output? Timer. That's all. Once the timer elapsed, it has to open the outlet valve. It has to open the outlet valve. For that, we have to include M0. All runs included with M0. Then, what is required? Oh, okay. What is required next? T0 will trigger the outlet. So, we have to use T0. If T0 becomes 1, it will start. Then that's all. But when the outlet valve has to close, it becomes empty. It becomes empty. Empty means 1. So we can include X2 as such. We can include X2 as such. Till then it should open. So X2 as such we can include. Is it okay? Yes. Okay, but problem is there. What is the outlet valve? Number? Y4. It will work, but the problem is this X3 means what? X3 means high level. That once the outlet valve is opened, it will drain. That's why T0, after some time, T0 becomes 0. T0 becomes 0. So across T0, we have to put a sealing contact. So we will change this into T0 because we have to put a sealing contact. If it is in the beginning, it will be convenient. That's why we will make this as T0. And this will make it as M0. You need a sealing contact, M0. So here you need a sealing contact. Why? After some time, T0 becomes 0 because here X3 is in series with T0. It won't be 1 forever. It will start, then after some time, if it falls below that, The tank is not full. That's why X3 becomes 0. X3 becomes 0. That's why it will not work. That's why we have to include a sealing contact. That sealing contact is Y4. Y4 is the sealing contact. Y4 is the sealing contact. Y4 to keep it on. That's all. That's all about programming for the batch process. We have to verify this. We have to verify this by running this. We'll verify. Why sealing contact is required? X2 is what? X2 will be full means 0. When it has to open, full means it has to open. So it must be normally closed. Normally closed, because when empty it becomes 1. When empty it becomes 1, outlet valve will be closed. When it becomes empty, it becomes 1, it becomes 0 here. Automatically it becomes 0, because that's why I put a NOT gate. So outlet valve will be closed. That's all. That's all about the program. Now we have to compile and verify this program, whether it is working or not. We will verify. Yeah, first, let us save this. Then we will compile. Compiled. Now we have to simulate. Run. It is in run mode. First thing, we have to turn on the program. Program is not functioning. That's why M0 is required. When everything is ready, then only we will turn on the program. If you turn on the PLC, the program should not work. That is our idea. If you press the start button, then only the batch process will start. So I am pressing the start button. So I am pressing the start button. Set on. Set off. But what is the status of empty is not 1. Empty is not 1. Empty must be 1, you know. The X2 must be 1. Where is X2? Because now it is empty, you know. That's why we have to set on. Y1 is turned on. It means inlet valve is open. After some time, what will happen to that proximity switch, lower proximity, bottom proximity switch? It becomes 0, because level will raise above that proximity switch. That's why it is not empty. That's why it becomes 1. It becomes 0. Am I correct or not? That way we have to simulate. Still, inlet valve is on. Once the level is reached, what will happen to X3? X3 becomes 1. Tank is full, X3 becomes 1. Anywhere you can change. Here I can change. Anywhere. Here or here you can set. Let us set here. I am set on. Tank. Heat is turned on now. Y2, Y3 is turned on. Now, X4 must be 1. X4 must be 1. It means temperature is reached. The transmitter will give 1. Now, X4 has to be 1. We are making set on. What happens here? After a delay, outlet valve is opened now. Outlet valve is opened. Now it is draining. We have to imagine like that. Now the tank is draining. First, what will happen? First X3 becomes 0. First X3 becomes 0. So we have to change that first. Still, the valve is open. It is functioning correctly. Still, the valve is open. Now, after some time, what will happen? It completely drained. Am I correct or not? Completely drained. Completely drained means what? X2 becomes 1. X2 becomes 1. X2 set on. Inlet valve is opened. Again and again it will do. Again and again. Drain, it will fill, heat, wait, drain. Fill, heat, drain, wait, drain. Repeatedly it will do. So this is called the batch programming. It works fine. So outlet valve is closed. Once it becomes empty, outlet valve is closed. The correct sequence of signal we have to give. Otherwise, you cannot verify the program. Okay. That's all. Let us stop here.